Hi everybody, in this video I'm going to show some examples of how to convert between moles, molecules, and atoms. This is something we learned earlier in the year, but it is in this Apex section, so you might have forgotten, so we're going to go over it together. So the first thing to think about is that molecules and atoms are treated the same. And I'm going to go through what that means in a second. Okay, and the key idea here that drives these calculations is that 6.02 times 10 to the 23rd atoms or molecules equals 1 mole, okay? So let's do some examples to look at what this means. Okay, so in this example, we're going to show how to convert between moles and molecules or atoms. So our question is, how many molecules are present in 3 moles of MgBr2? Okay, so first we're going to set up our train tracks, and we're always going to start out with this number that we're given. We're given 3 moles, so we're going to put 3 moles here. Now, if we look at our conversion factor, we know that 1 mole equals 6.02 times 10 to the 23rd atoms. We want moles to cancel, so we're going to put it on the bottom. And then we have to put 6.02 times 10 to the 23rd molecules on top. And we see that mole would cancel and we'd be left with molecules. And that's what we were asked for. So I would just put this in my calculator. I would do 3 times parentheses 6.02 times 10 to the 23rd, close parentheses. And I would end up getting 1.8 times 10 to the 24th molecules. And that would be our final answer. Pretty simple. Let's do one more example in the other direction. So for this example, we're going to go from molecules or atoms to moles. So our question here is going to be, how many moles are in 2.7 times 10 to the 25th atoms of sulfur? Okay, in this case we're using atoms. The process is the same whether it's atoms or molecules. So again, the first thing we do is figure out what number we're given, which is this 2.7 times 10 to the 25th atoms. Now we make our train tracks and we put what we're given in the beginning. Okay, so we have atoms on top, which means we want atoms on the bottom. And we know that 6.02 times 10 to the 23rd atoms equals 1 mole. Again, I put the atoms on the bottom so it would cancel, and we see that it does, and we would be left with moles as our unit, which is what we were looking for. So now I just put this in my calculator. I would do parentheses 2.7 times 10 to the 25th, close parentheses, divided by parentheses 6.02 times 10 to the 23rd, close parentheses. And I would end up getting 44.9 moles of sulfur, and that would be my answer. So these are just one-step equations, and it's using that key idea that 6.02 times 10 to the 23rd atoms or molecules is equal to 1 mole. Let me know if you have any questions.